Our lesson today is 10-2, Simplifying Radical Expressions. Our essential question says, how do you simplify radicals using the product property? So a radical expression is an expression that has a radical in it, and radical means square root. So an expression with a square root in it. Remember that an expression in math can have numbers, it can have variables, and it can have operations, like adding, subtracting, multiplying, and dividing. It doesn't have an equal sign, though, because that would make it an equation. Simplest radical form. Simplest radical form is when all perfect square factors have been removed from the radical. So when there are no, let's see if I can word this a little bit differently. When the radical, so that would be the square root, when the radical does not have any perfect square factors left. Okay, so in the radical, the number under the square root does not have any perfect square factors in it, then that means it's in simplest radical form. That probably doesn't make a whole lot of sense to you right now, but hopefully as we work with it, it will. The product property. We've kind of worked with this a little bit. The square root of a times the square root of b is the same as the square root of a times b. So you can multiply together the two numbers that are underneath the square root symbols, the two radicals. You can multiply them together and write them as one square root or one radical instead of two separate. And then sometimes that helps because you can simplify it from there. All right, so let's try to use these new vocabulary words right in simplest radical form. So as a reminder, we've got some perfect squares. So I'm going to write some perfect squares up here just to get you thinking about what our perfect square numbers look like. So here's a few of them. Okay, now to simplify the square root of 80 and keep my answer in simplest radical form, I don't want the answer to be a decimal. So no decimal answers. I want to keep it in radical form as a square root, but I want to simplify it if I can. And just simplify it, kind of like when we reduce fractions, you know, the same idea. We're going to simplify radicals by looking at these perfect square numbers, and if any of them are factors of our radical, we are going to factor out the perfect square. So, for example, 80, I happen to know, is the same as 16 times 5. So if 80 is the same as 16 times 5, I can split 16 and 5 and write them as their own radicals, and then I know that the square root of 16 is 4. So in simplest radical form, the square root of 80 is 4 times the square root of 5. That is my answer in simplest radical form. So I'm not doing a decimal approximation, I'm keeping it radical form, but I'm simplifying it until the number that's left under the square root does not have any perfect square factors. Let's try the next one, the square root of 54. So if you look at my list of perfect squares across the top, what you're looking for is the largest. Look for the largest perfect square factor. The largest perfect square factor. Okay, the largest perfect square factor for 54 is 9. 9 times 6. So I can split it, and then the square root of 9 is 3. So my final answer in simplest radical form is 3 times the square root of 6. The last one is the square root of 120. 120. If I look at my choices up there, you may think, I don't know, maybe I'm not so good at this, so let's just kind of break it down. I know 4 goes into 120, so let's go with 4. 4 times 30. So the square root of 4 times the square root of 30 would be 2 times the square root of 30. Remember, when you take the square root of 4, it becomes 2. It's not a radical anymore. Now the square root of 30. If I think about where the square root of 30 would be, it's in here. So I would want to look at all of the numbers smaller that are perfect squares to just make sure that I've got simplest radical form. So the number 30, it's not going to be divisible by 25 evenly, not 16, 9 doesn't go into 30, 4 doesn't go into 30, and 1 goes into everything. That's not going to help me simplify it. So I have got it, 2 times the square root of 30. So those 3 examples are simplest radical form. What's important about simplest radical form is that it keeps your answer exact, because you're not rounding, you're not approximating. It's still an exact answer, which can be very, very important when you work with precision. Now, write in simplest radical form. Okay, so just like on the last one, the difference though is that these are written as separate square roots, and they're not perfect squares. So I'm actually going to multiply them and put them back together first. 12 times 6 is 72, because now if I break down 72 differently, I could use 36 times 2, and then the square root of 36 is 6. So simplest radical form is 6 times the square root of 2, which you may not have seen from the original problem. So multiply and put them together using that product, the radical product property. 18 times 2 is 36, and then you may realize that it's even a perfect square, like this one. The square root of 36 is 6, so I'm done with that one. And then 5 times 10, 5 times 10 is 50, and I can break down the square root of 50 because 25 is a perfect square. 25 times 2, so this one would be 5 times the square root of 2, like that. So you're looking for, again, the largest perfect square factor, the largest one, the largest one. Let's say if I go back up here to the top and I show you with the square root of 72, what happens if you said, well, 72 is 9 times 8. 9 is the square root of 3, so I think it's 3 times the square root of 8. The problem is 8 has another perfect square factor because 8 is 4 times 2. So then I would have to simplify even longer. Square root of 4 is 2, so 3 times 2 is 6, 6 times the square root of 2. This process took a lot more steps to get to my simplest radical form because I didn't use the largest perfect square factor the first time around. So please make sure that you're looking at the list of perfect squares and you're really trying to find the biggest one, because then it will be a lot quicker simplifying process. Okay, next. Now we've got some radical expressions where we have a number, kind of like a coefficient with a variable, a number in front of the square root. Now remember that the commutative property said it was fine to change around the order that you multiply. So I can change around this order like this and multiply all of these together in a different order. 6 times 5 is 30, and then 8 times 2 would be 16. So 30 times the square root of 16, well, the square root of 16 is 4, so 30 times 4 gives me 120. So it's not a radical at all anymore. Let's try the next one. 4 times the square root of 5 times 3 times the square root of 10. So I'm going to put my 4 and 3 together, and then my square root of 5 and square root of 10. So 12 times the square root of 50, well, the square root of 50 breaks down because the perfect square factor it has is 25. So 25 times 2. So now it's 12 times 5 times the square root of 2, or 60 times the square root of 2. For my final answer in simplest radical form. Okay, the last one, 3 times the square root of 3 and 2 times the square root of 24. Hopefully you're getting the hang of this. So I'm going to multiply together 2 times 3, and I get 6. And then the square roots, if I multiply them together, 24 times 3 is 72. So 72, we saw this one earlier. The best way to split it is 36 times 2. So the square root of 36 is 6, and the 2 is still under the square root. 6 times 6 is 36, times the square root of 2. Simplest radical form. All right, our last slide. Write in simplest radical form, and now we've got some variables here, So the square root of 90 x squared y to the 4th. Here's what I'm going to do. I am going to split it up. So the square root of 90. 90 is 9 times 10. So 3 times the square root of 10. The square root of x squared. Well, hopefully you remember that x times x is x squared. So then the square root of x squared is just x. Y to the 4th. Well, y to the 4th is y squared times y squared. So y to the 4th would be, the square root of that would be y squared. So I'm going to do a little bit of reordering here. I'm going to put the 3x and y squared in front so that you don't think they're under the root. Only the 10 is left under the square root. So when you have an even exponent, you are going to be able to think about it as a perfect square. Now, on this next one, you may notice that we've got some odd exponents. So what I'm going to do is, I'm going to go with an even exponent and then take that odd one out and leave it on its own. And with the y's, the same thing. 4 of them would be even, and then that 5th one is odd, so that one's going to be out. Because perfect square, if you're splitting it to get a perfect square, the even exponents are perfect squares. Now, there's something else I can do. With my 32, that would be 16 times 2. So now look at what I've got. I've got a lot of different radicals here. Now I'm going to do the perfect squares first. So I've got 4 for this one, because it's a perfect square, x for this one, and then y squared for this one, because it's a perfect square. I also have this 5 that was out in front. So now what that means is, in front of my square root, 5 times 4 is 20, and then I have the x that I took out, and the y squared, and then what's left under my square roots, I've got a 2, an x, and a y that were not perfect squares. So they stay under that radical. So there's my simplest radical form for this problem. Okay, last one. 2, the square root of 8, square root of x to the 10th, square root of y, square root of z squared, and then I'm going to go with that separate z because that one was odd. And then 8, I'm actually going to change this to 4 times 2. So now, perfect squares. 2, x to the 5th, and z. So 3 of them are perfect squares, and the 2 that was out in front. So 2 times 2 is 4, x to the 5th, z, and then under my root, 2y, z. 2y, z for my final answer. Simplest radical form. So remember, if it's an even exponent, so that one I just did was like x to the 5th times another x to the 5th is x to the 10th. If it's an even amount, it's a perfect square. If it's an odd amount, take one of them out, and then the rest of it's even, so it's a perfect square. You should be able to write a summary now. And here are your homework problems in your textbook.